Hi, my name is Edgar Tulcam. I'm 30 years old. I'm a professional chemical engineer and I'm a student of BYU pathway of the software development. And today we are going to discuss two common pitfalls of recursion of how to overcome them. The first major pitfall is the risk of a stack overflow. Every time a recursive function and you call itself, it adds a new frame to call a stack if the reunion goes to the tip, either because the input is very large or the base case is missing or incorrect. The program can run out of stack space and crash. A classic example is recursive function that accidentally never reaches in its base case. There are several ways to avoid this issue. One option is rewrite the algorithm in retrieval using loops, which use constant stack space. And another option in language that support that is to use two-tail recursion, which can be optimized by the compiler and the review of stack frame. And finally, we can simulate recursion manually using an explicit stack and address structure, which allow us to control the memory usage of safety. The second major pitfall or recursion is poor performance caused by repeat work. Some recursive functions perform the same calculation over and over. A common example is the naive recursive Fibonacci functions, which recalculate value exponentially many times. This can make the program slow even for relative small inputs. To solve this problem, we can manage that is memorization store of the result of the previous function calls and reuse when the same input occurs again. This can reduce the time and complexity of the exponential to linear. Another option is to avoid recursion algorithm or the use dynamic programming, which solve subproblems from the bottom up and save all internal inmates.